So 0 square, that is 0, 1 square, that is 1, under root of 1, that becomes 1. So our mod z, that becomes 1. So we find here two answer, z bar, that is plus I, and mod of z, that is 1. So our result, that is 2. Now we move to our next question. Our next question, that is B, for question 5b. First question, that is solve the differential equation dy by dx is equal to x plus y whole square. So we write B, first equation, dy by dx is equal to x plus y whole square. So we want to find the differential equations or solving the differential equation. This is the term of x plus y whole square. So we assume x plus y at present here v. So let x plus y is equal to v. Now if we differentiate this equation with respect to x, so our above equation, that becomes d by dx of x plus y, that is differential again with respect to x, that means d by dx of y is equal to differential with this respect to x, that becomes d by dx of v. Now simplify, 1 d by dx, they both are cancel out. So 1 plus dy by dx is equal to dv by dx. So we replace dy by dx over here. So result of the dy by dx, that is nothing but only dy by dx, that becomes dv by dx minus 1. So we replace our dy by dx, that is dv by dx minus 1 over here in our equation. So our equation, main equation, that becomes dv by dx minus 1 is equal to x plus y whole square, but in starting of our sum we assume x plus y is equal to v. So replace x plus y, both the term only v, so that becomes v square only. So our final result, that is dv by dx minus 1 is equal to v square. Now we arrange this equation, that becomes, so dv by dx is equal to v square minus 1, from left hand side to we move to right hand side, that becomes plus 1. Now we arrange our this term only v side, and here left, RHS side only x side. So our left hand side becomes dv by v square plus 1. We move v square plus 1 to denominator side of left hand side equation, and dx, that is over here. So our equation becomes only v side, and this equation becomes only x side. Now we integrate both the equation, that is integration of dv v square plus 1 is equal to integration of dx. By rule of the integration, v square plus 1 upon v square plus 1, the result, that is tan inverse v. So we directly write our answer by the rule of the integration. So tan inverse v n by 1, so v by 1 is equal to integration of dx. So by default constant we assume here, so integration of 1 dx, so 1 integration, that is nothing but x only, and final x plus c. Now v, that is replaced by x plus y, so replace our final equation with x plus y only. So result, that becomes tan inverse x plus y is equal to here x plus c. So this is our final answer. We solve the differential equation. Our result, that becomes tan inverse x plus y is equal to x plus c. Now we move to our next question. Our next sum, that is question 5b2. Again solve the differential equation x dy by dx is equal to y plus x cos square y by x. So we write down this equation. Second sum, b second, x dy by dx is equal to y plus x cos square y by x. So we solve our equation here, x dy by dx. So if we divide all the equation by x, so our above equation that becomes only dy by dx x, and all the equation we want to divide with x. So x dy by dx by x is equal to y again divided by x plus second equation, that is x cos square y by x we want to divide with x. So above equation, that is nothing but we want to divide by x. So now we simplify this equation. Here x both are cancel out, so dy by dx only is equal to here y by x place as it is, plus again here x and x both are cancel out, so only result, that is cos square y by x. Now if we assume y by x is equal to v, so let y by x is equal to v. So our above equation, so y by x here replace with v, and here again y by x replace with v. But dy by dx we want to also find out, so differential this equation with dy by dx also, so we also replace dy by dx also. So y is equal to here x into v, we want to replace also dy by dx, so again differential above equation y is equal to xv with respect to x, so that becomes dy by dx is equal to here x into v. We apply here multiplication rule of the differential equation. So first term, that is as it is, first term, that is x, differential of the second term, that is nothing but d by dx of v, plus second term, that is v as it is, and then differentiation of last term, that is nothing but d by dx of x. Now we arrange above equation, so dy by dx, that is as it is equal to x dv by dx plus v dx by dx, that is cancel out. So our dy by dx result, that is x dv by dx plus v, that is replace here, y by x, that is replace with v, and cos square y by x replace with again cos square v. So we simplify this equation, equation number 1, to our result. So that is becomes, our equation now becomes dy by dx, that becomes x dv by dx plus v. So our equation number 1, dy by dx, that we replace with our result, dy by dx is equal to x dv by dx plus v. So here x dv by dx plus v, y by x, that we assume already with v, so replace y by x with v, plus cos square y by x, that becomes cos square only v. So our equation becomes x dv by dx plus v is equal to v plus cos square v. Now we analyze our this equation only, so that becomes here v and v both are cancel out, and arrange this equation only left hand side only v and right hand side only x. So our equation becomes dv this cos square v, that is divide with left hand side, so here cos square v is equal to dx left hand side to RHS side, so that becomes dx, here x that is multiply, but we want to move to RHS side, so that is divide. So our above equation that becomes dv cos square v is equal to dx upon x. Now we want to find out v and x, so using integration we can find out easily v and x value. So integrating our above equation, that becomes integration of dv cos square v is equal to integration of dx upon x. Using the rule of the integration, first of all we want to simplify left hand side equation, so 1 upon cos square v result, that is sec square v. So 1 upon cos square v, that becomes sec square v, and dv as it is equal to integration dx by x as it is. Now I want to take the integration of sec square v dv, so differentiation of the tan v, that is sec square v, so integration of sec square v, that becomes tan v. So result of the integration of sec square v dv, that becomes tan v is equal to integration of 1 upon x dx, that is nothing but log x, and constant value, that is plus c. This is our result, but v, that is our assumed value, so replace v by original value, that is y by x, so replace here y by x, so our final result, that becomes 10 y by x is equal to log x plus c. So this is our final answer. Now we move to our next question. Our next question, that is z is equal to 3 divided by 1 plus under root 2i, then prove that z square minus 2z plus 3 is equal to 0. Find the value of z cube plus z square minus 3z plus 10. So we want to write down first the question. So question, there is question 5 b. Third question, z is equal to 3 divided by 1 plus under root 2i, and we want to prove z cube minus 2z plus 3 is equal to 0. So first of all we arrange our z term by x plus iy form. So we want to arrange this equation into x plus iy form first. So we take conjugate of z, so 3 divided by 1 plus under root 2i, so divide and multiply with 1 minus under root 2i in numerator and denominator side. So 1 minus under root 2i, also in numerator side 1 minus under root 2i. Now we simplify this equation, so our equation becomes 3 into 1 minus under root 2y with bracket divide by here 1 plus under root 2y and 1 minus under root 2y. So our equation that becomes a plus b and a minus b form. So a plus b into a minus b, the result that is a square minus b square. So 1 square that becomes 1 minus under root 2i square. So under root 2i square whole square. So that is a square minus b square form. Now we simplify numerator side and denominator side first. So here 3 into 1 minus under root 2y divided by 1 minus. So first of all under root square, under root 2 square, that becomes 2 I square place as it is. Now again we simplify 3 multiply by 1 minus under root 2y. Here I square that is replaced by minus 1. So here minus sign that becomes plus. So 1 plus 2, because I square that is minus 1, so minus 1 that is multiplied with minus 2, so minus 2 becomes plus 2 only. So finally 3 into 1 minus under root 2y, here 1 plus 2 that is nothing but 3. So these 3 and numerator side 3 that is cancel out. So our z is equal to one minus under root 2y. So our z value that is 1 minus under root 2y. Now we want to place this z equation into above equation, that is z cube minus 2z plus 3. So and we want to prove this equation is equal to 0. So replace this equation by 1 minus under root 2y. So our above equation that becomes z cube minus 2z plus 3. So replace z with this value 1 minus under root 2y. So 1 minus under root 2y cube minus 2 1 minus